Inference for linear regressions. So when I say inference, I mean significance tests and confidence intervals. So I'll say sig tests and CIs. We did not do confidence intervals for chi-square. Wasn't that nice? But now we're going to have to go back and do some confidence intervals. So let's try to think about why we do inference. So what we're doing with inference is we are estimating a population or predicting a population based on a sample. Okay, so that's the concept of inference. So when we did linear regressions before, we probably had samples that we were dealing with, but we just analyzed the sample. Now we're going to take that a step further and say, well, from this sample, can we come up with a regression line for the entire population? Okay, so first we'll get a sample. So let me give you a sample that I did last period select because I know it's in my calculator. We're going to do this again. I was going to try to gather data, and then I realized that takes so long, and I just didn't feel like doing it. So we'll use some data out of your textbook. Hang on. Wrong chapter. Hang on. 15 point. That's coming. So get out your calculator. Where is everybody going? Why are we all checking the trash can? It's a transaction. Oh my God. Oh. Okay, here we go. Here's some data. Hopefully you can read this. This is from an experiment to see if fidgeting and other non-exercise activity, NEA, might help explain weight gain in individuals who overeat. So here are non-exercise activities and the number of calories that they burn, and it would be negative calories. What kind of activity? It's some kind of change. And it's a change in calorie burned. Okay? And here is the fat gain for those people, I guess. Yeah. Okay. So the NEA change is in 2 rows here. The fat gain is in 2 rows here. So why don't we put this in list 1, that in list 2. This is going to be the end of list 1, the end of list 2. Can you read those numbers? All right, list 1, you ready? Negative 94, negative 57, negative 29, 135, 143, 151, 245, 355, 392, 473, 486, 535, 571, 580, 620, and 690. 690, yes. Okay, your list 2, 4.2, 3.0, but you don't put the 0.0 because your calculator will just ignore it anyway. Okay, 3.7, 2.7, 3.2, 3.6, 2.4, 1.3. Are you now matching up with the 392 as your next entry?
Yes.
If you're not, then go back and fix your list. All right, 3.8, 1.7, 1.6, 2.2, 1, 0.4, 2.3, 1.1. Andrew, are you making deliveries today? Yeah, you should, because that's for Thursday, so go ahead and get those out. All right. So we have a whole bunch of numbers in list 1. How many is it? 1, 2, 3, 4, 5, 6, 7, 8. 16 numbers in list 1, 16 numbers in list 2. Is that what you have? Yeah? Okay. Then we're good. All right. So, what did we do? Let me de-zoom this a little bit. We got a sample, and we want a least squares regression for this sample. So tell me some things that we did back last fall. We were looking for associations. Anybody remember? We did residuals. What other kinds of things did we do? We didn't do extrapolations, yes. Did we maybe look at the data in a what kind of form? Scatter plot. Okay. What else did we do? Oh, we got correlation and coefficient of determination. What else did we do? All right, so we're just going for linear this time. So my linear least squares regression line, I'm going to write in the form a plus bx. We don't write it mx plus b or ax plus b. We write it a plus bx. Because when we do multiple regressions in statistics, we keep writing out more constants, or they're not constant, more coefficients and different x's. Excuse me. All right. So these are the kinds of things we did before, and we'll go through doing those again. So first off, why don't we get our regression equation? Calculator. What buttons do we press to do this? Okay. Okay, let me turn the light back on, maybe.
Wait, are you filming these?
Yeah, I am actually filming the notes, even though they're on paper. All right, so now how do we get this y hat? Stat. Calc. Now we're not going to do number 4. We're going to do number 8. Oops, that's number 9. Okay. And you can tell it list 1 comma list 2, or you can just hit enter because its default is list 1 list 2. Okay. Got some nice numbers here. Let me write my regression equation. That is y hat equals, I got 3.505, I'm just going to 3.5, minus 0.0034x, where y is the predicted fat gain and x is the change in NEA. Okay. Oh, I got an r. We can do an r or an r squared. I don't care which one you want to record. I'll re-squared r. Negative 0.779. Scatter plot. How do we get the scatter plot? Second y equals. So there's mine. Turn that plot on. Make a scatter plot. Make sure I got nothing in my y equals here. And I do a zoom 9.